Namaskar students. I am Nitesh Kumar Jangid, Assistant Professor, Department of Textile, Panipat Institute of Engineering and Technology, Samal Khan, Haryana. In this online lecture series, we will take the Theory of Textile Structures 4th unit. This course is taught in 3rd year 6th semester textile technology students. I hope you'll enjoy and learn from this lecture series. This is your 4th unit syllabus, from which we'll take first topic, the elements of fabric geometry in this lecture. For this topic, I have referred Woodhave publications, Woven Textile Structure, Theory and Applications by B.K. Bera and P.K. Hari. There are many ways of making fabrics from textile fibers. The most common and most complex category comprises fabrics made from interlaced yarn. These are the traditional methods of manufacturing textiles. The most common form of interlacing yarn is weaving. In weaving, there are two sets of threads which are interlaced with one another. Other form of interlacing is knitting, in which only one set interlocks with the loops of neighboring threads. There are other forms of fabrics are also available, like non-wovens and braiding. But in this unit, we will discuss the woven structure and their properties. Basic material needed for weaving are two sets of threads. The first set is called warp and second set is called weft, and it goes back and forth between the warp. The warp threads are along the length of the fabric and weft threads are along the width of the fabric. Individual warp threads are called ends and individual weft threads are called picks. And their interlacement produces a coherent and stable structure. The repeating unit of interlacement is called the weave. Weaves can be classified into two categories broadly: regular weaves and irregular weaves. Regular weaves gives a uniform specific appearance to the fabric. The properties of the fabric for such type of weaves can be easily predicted because their repeating unit is very regular. Some of the example of such type of weaves are plain weave, 2x2 mat weave, 1x3 twill weaves, 1x4 satin, 2x2 warp rib and weft rib, etc. Irregular weaves are commonly employed when the effect of interlacement is marked by the colored yarn in the fabric. Such weaves are common in furnishing fabric. In such structures, the prediction of mechanical properties is very difficult. Example of such kind of weaves are 4-end irregular satin and 6-end irregular satin, etc. Now, the weave factor. The weave factor is a number that accounts for the number of interlacement of warp and weft in a given repeat. It is also equal to average float and is expressed mathematically by formula m is equal to E by I, where E is the number of threads per repeat and I is the number of interlacement or intersection per repeat of the cross thread. The intersection is the point where the thread goes up from the downside or down from the upside. The weave interlacing pattern of warp and weft yarns may be different. In such cases, the weave factor are calculated separately for warp and weft. For warp, it is represented by M1 and expressed by M1 is equal to E1 by I2. Factor weft-wise can be expressed as M2 that is equal to E2 by I1. For better understanding, let's take an example of calculation of weave factor. First, take the simplest one. For plain weave, we know that the weave is represented by 1 by 1, or we can say 1 up and 1 down continuously. So, number of ends per repeat is equal to 1 plus 1 is equal to 2. And number of intersection per repeat is also equal to 2. Here we can see 1 and 2. Now, if we put both the value in the formula, we'll get M is equal to E by I, that is equal to 2 by 2, and we get the value of M is 1. So we can say that the weave factor for plain weave is 1. Let's take another simple example of 2 by 1 12. We can see that ends per repeat in such 12 is 3 and interlacement in warp direction is 2. One is right here and other one is here. And E2, that is the picks per repeat, is equal to 3 and I2 is equal to 2, that is the number of intersection weft wise. So now we calculate M1 and M2 by the given formula. M1 is equal to E1 by I2 and M2 is equal to E2 by I1. We find that the M1 and M2 are equal, that is 1.5. Let's take another example, that is 2 by 2 warp rib. E1 for such weave is 2 and E2 is 4. I1 is 2 and I2 is also 2. So calculated value of M1 and M2 are 1 and 2 respectively. Now take other example, that is 2 by 2 weft rib. We can see that E1 is 4, E2 is 2, I1 is 2, I2 is 2. So M1 is equal to 2 and M2 is equal to 1. In irregular weaves, the number of intersection of each thread in the weave repeat is not equal. So in that case, the weave factor is obtained by summation of E divided by summation of I. Equation. Let's try to calculate the weave factor for a 10-end irregular huckleback weave. We can see that there are 10 ends and for every end there is unequal number of intersections. So first we start with the first end. At the first end you can see that the weave goes like 1 up and 1 down, 1 up and 1 down, and 1 up and 1 down 10 times. So the number of intersection for the first end is 10. Similarly, if we see at the second end of this weave, the intersections are here like 1, 2, 3, 4, 5, and this 6. And similarly, if we count the intersection for the third end, these 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. For the fourth end, the number of intersections are 1, 2, 3, 4, 5, and 6. Similarly, for fifth end, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. For sixth end, 1, 2, 3, 4, 5, 6. Number of picks per repeat for every end are equal, that is 10. So V factor can be calculated by summation of E divided by summation of I, that is equal to 100 divided by 84, and we found the V factor 1.19. So this is all for the day. I hope you have enjoyed the lecture. We'll get back to you in the next lecture. Till then, stay home, be safe, goodbye, thank you.